Hello, GraphQL Summit. My name is Chung, and this is me. I work at a company called Coursera. We have over 2,000 courses on our platform from over 150 partner universities from around the world. And so most of our product developers at Coursera spend a lot of the time building a great course experience online. But actually, that's not what I do. I'm actually a front-end infrastructure engineer at Coursera. And so I'm focused on how can we actually make our product developers more productive. So something that got me really excited when we started diving into GraphQL itself was, hey, we now have this schema thing that we can build tools off of. Is there a way to get to a point where all of our data access in our client applications are type safe, right? And so as I was looking around, I found a project called Apollo-Codegen. And I saw that there was rudimentary support for Flow and Typescript. And so I jumped right into it and said, could I help out? They gladly said yes. And so I wanted to share with you guys why I think you guys should all be interested in Apollo-Codegen. So to do that, I'm going to go over three things today. What is Apollo-Codegen? Why should you use it? And how you can actually use it. So starting with what is Apollo-Codegen? Well, Apollo-Codegen is a tool that aims to bridge type systems using the GraphQL type system as the input type system. And then it's able to generate many different type definitions for different type systems. And actually, Apollo Android and Apollo iOS that was mentioned earlier today uses this under the hood. So how is it able to do this? Well, actually, in your applications themselves, you have all the information you really need to do this. The operations and fragments that you define are specifying what is the shape of the data that you're accessing. Combine that with the introspection schema that is provided by your GraphQL server, you know what the types of all those fields should be, right? So what I've actually focused on is actually working on the Flow and TypeScript targets for Apollo-Codegen. And I don't really want to go into too much detail about how this works under the hood. But basically, if you have queries in your applications that look like this, we generate a type definition file that looks like this that you can then use within your application. Right? So that's kind of cool. But why use Apollo-Codegen? Why add this tool to my application? It's just going to make things more confusing. And I want to kind of explain this first by talking a little bit about JSON. Right? So on one hand, we've been using JSON forever. Right? And we actually love JSON. Actually, one of the first demos that I saw about GraphQL was that you could send a JSON-like document and get JSON back. And that was awesome. But on the other hand, we lose type information with JSON, right? We lose the type relationship information between our data objects. And so I kind of like to think about this as if like you're reading an abridged book. You kind of understand what's going on, but you don't really understand the nitty-gritty details anymore. So why is this a problem? I think this is best demonstrated by going through kind of an example. Let's say that I wanted to create an episode hero display component that looked something like this. Very simple. It displays the name of our hero per episode and the origin of that hero, right? And there's also, like we were provided with this magic function that somehow does something to this origin value that we have. And we're just expected to use it. It takes a string and then returns something that's renderable. So to start on this task, we might look into our resolvers in our schema. We see this resolver that we want, a hero resolver. And we notice that the input to this resolver is an episode, and episode is an enum, right? And then it returns a character of some sort. We might also notice that for all the return values here, they're all human, right? So we might notice that there might be this relationship between character and humans. So we dig into our schema, and we notice that there's actually a character interface, and there are two implementations of character, right? So this is cool. I'm going to actually go on and start implementing what needs to look like this. So what we might end up doing is then writing our kind of writing a quick query to get all the information that we need. We need the name, right, Leia Organa, and we need her origin, which is her home planet. So we write an inline fragment with the human type condition and fetch the home planet. We throw all the episodes we know that exist on this resolver into this, and we get back our JSON. And we're like, cool, we kind of understand what we're doing here. And then we write our component, right? Very simple. There's two things being displayed here, the name, the origin, and we kind of, as I said before, we pass the home planet into this magic function. So we might even QA this and try everything again in production, and everything looks good. So we commit our code, deploy it, move on. But we made a mistake here, right? Because In our backend, we had actually said that this resolver returns any sort of character, right? And humans aren't the only kinds of characters. So if someone came in and modified this resolver to return a droid, this wouldn't be a breaking change of any sort, but it's something that would go unnoticed. So, and the droid itself doesn't have this home planet field, right? So what happens is someone could commit this change to the resolver, and all of a sudden there's a case where your clients will now have a runtime error, right? Because hero.homeplanet doesn't exist for the case that the hero is a droid. So let's rewind, right? And let's see what happens when we add Apollo-Codegen to the mix. So we had originally written this resolver, this query. And if we actually run Apollo-Codegen, it would generate out a type with the type signature that looks something like this, right? And this maps very well with the actual query that we wrote. There are two possible types here. There's human and droid, and humans have the name. And since we have that inline fragment on human, we get the home planet field there. But for droid itself, we only get the name field. So if we actually then annotate our component with this type that we got, then and we run our type checker, right? Then we would actually see right away that, hey, there is an error here, right? We missed this case before. And again, we missed the case where hero itself is a droid because there's no home planet field on droid. So as we see this, we can go ahead and fix it and say, OK, actually, for the origin for a droid, we want the actual creator. So we can modify our query to pull that in. And then rerun Apollo-Codegen to regenerate these types, right? And then we'll notice that, hey, this is a disjoint union that we need to handle. So we can just go ahead and modify our code. And so then we're handling all of the possible cases here, given the types that were specified in our GraphQL schema. And then if we were to run the type checker itself again, we would get no errors, right? So this all happens at the really beginning. Then someone else can come along and add this new episode where it returns a droid hero, and it's not a big deal, right? Nothing breaks because we're good because we have the types defined in the schema itself, propagating all the way to our clients, and we satisfied all the needs defined by those type definitions. So there's another thing that I wanted to go over, right? This is the that field is nullable problem, and this usually crops up in your applications when you get runtime error in production that looks something like this, right? Cannot read property of something of null. And I saw this happen the first time at Coursera when someone wrote what looked like a harmless query, looked something like this, and they wrote code that looked like this, that looked very harmless. But what they forgot to do was actually check the schema and understand that that starship field is not marked non-null, so it's possibly nullable, right? So if you were to actually run Codegen, Apollo-Codegen, you would see that the type signature for this actually looks like this, right? So if you were to then annotate that variable with this type, you would get, when you write this code here, it would, and then you run your type checker, you would then see that the starship itself could be like there's something wrong here, right? You need to fix this. So this is the benefits of kind of having a system that is able to generate, that's able to bridge different type systems. You get all these guarantees at compile time rather than waiting for a runtime error to occur. Right? And another thing that I wanted to bring up is that types can sometimes be confusing for humans. Right? The tools that we build will always get these right because we've only had to write it once and test it once. But if we're trying to read these types and understand them, we can make mistakes. So for instance, here are 4 examples of different kinds of lists of friends. Right? And if you were to interact with these incorrectly, then that could be another error with nullability. And actually, this is how you'd actually convert these to like a kind of like flow type definition in this case. And so if you let the tool do this for you, then you never have to do this. And you can always make sure that if you're using these types, when you interact with this data, that you'll always get it right. So you might be saying that like, OK, I actually reference the GraphQL schema all the time as I'm writing my front ends. I don't usually make mistakes like this. And what I want to say is, well, queries can get really complex, right? Especially when your apps get big. In the previous examples, I showed really just one field or one simple query. It's very possible to end up with a query that looks something like this, right? And every single one of these fields could be a point of failure, right? A point where you make a human error. And so what we can actually do is then just make sure that we're using generated types, right? That way we let the tools do these decisions for us. They tell us right away whether or not we're doing something wrong, and so we can remove that from our mental headspace. And so how do you actually use Apollo-Codegen today? It's actually very simple. If you're already using a language like Flow or Typescript, really all it is 3 more commands to add Apollo-Codegen. The 3 commands are globally install Apollo-Codegen using yarn or npm. Then we actually need you to download your introspection schema so that it's available locally. Apollo-Codegen provides a command to do this for you. And then there's just a generate command where you provide a glob pattern that points to where your GraphQL operations and fragments are. You point Apollo-Codegen to where your schema is, and then you specify the target, right? So here I've specified flow. If you use TypeScript, then you can just specify TypeScript. And so if you want more information about this, or if you want to get some information about where this project is going, it exists here on GitHub at apollo-GraphQL/Apollo-Codegen. If you have any questions, if you want to integrate this with your application today, feel free to come to the Apollo GraphQL Slack and join the Apollo-Codegen channel. We're super happy to answer any questions you might have. And the last thing I want to mention is that Apollo-Codegen 1 is actually in the works right now. We're not at 1.0 yet, but we have a lot of cool changes that we want to make happen before we declare a stable release. So if you're really interested in that, yeah, again, go to the Slack channel. Also, it might be scary to use Apollo-Codegen now. If 1.0 is coming out later, I guarantee that if we make any breaking changes to what currently exists, we will provide a detailed migration guide. So that's all I got. Thanks, everybody.